Hello everyone, my name is Ankit Nanwal and today we will be starting with the topic types of force system. So first of all, what is a force system? You all in earlier lectures I have told you about the word force. What is force? Force is the physical quantity that tends to change the state of rest or motion of a body. It is a physical quantity that changes the state of rest or motion of a body. So what is the force system? We talk about any system when there are number of forces that get increased. Suppose there is a system in which either two forces are acting or uh, you can say more than two forces are acting on a system, then it is said to be a force system in which more than two forces are acting. So together, when these more than two forces or two forces are acting on any system, they together are known as any force system. So there's a types of force system we will be talking about. First of all, force system is divided into two parts. You can say force system is a group of forces acting on a body. So force system is divided into two parts. One is coplanar and non-coplanar. So what is coplanar? Coplanar means that it is on a same plane, same plane, same plane. For example, you can take that there is a carom board. All of you must have seen carom board in which there are coins. There are certain coins over here. You strike with the help of a striker from here. So when you strike a striker from here, the coins displaces force to on different other coins. Okay, so these this type of system is having x coordinate or y coordinate. So in this system, the forces are acting on a same plane. Either it is xy plane or you can say yz plane or zx plane, any plane. So it is acting on a same plane. So forces are acting on a same plane. The coin which will be struck by a striker will have either it may move in x direction or y direction or somewhere else, but it will be on the same plane. Okay, but in case of non-coplanar system, in case of non-coplanar, now suppose there are some cases when you strike a striker here and this coin get um, lifted in the air and goes out. When it get lifted in the air, now when you strike a striker from an and this coin, it moves from the board, it tries to lift itself and goes out. So in that case, that coin will be having x coordinate, y coordinate, and it will be having some height also by which it gets fly out from the board. So that is having a z coordinate also. You can say z coordinate. So in that case, that system will be in case of 3D. We can say it is in 3D force system, and whereas coplanar force system, you can say it is a 2D system because it is on a same plane. Either it may be x y plane, y z plane, or zx plane, any plane. And you can say when the system is coplanar, so it is a 2D system. More than one plane is there, then it is a 3D system. Okay, and a non-coplanar force system is also known as space forces. Okay, when there is a 3D system is there. And coplanar forces are subdivided into three parts, that is concurrent, parallel forces, and general forces. And non-coplanar is also subdivided into three similar parts, that is concurrent, parallel, and general system. So what is concurrent force? Word concurrent means if the forces are applied on any, suppose this is a beam we are talking about. Okay, now this is one force and this is one force acting. So somewhere there they will be meeting at one point. So this type of force system is known as concurrent force system, where the point of application or is different, but they may meet at a single point. That type of force system is known as concurrent force system. Line of action of all the forces passes through a single point. Now, when you are talking about force, it is a vector quantity. It is a vector quantity. So, force is a vector quantity that is having magnitude plus direction. Magnitude, it is having some certain magnitude and direction. Suppose this is a object here. Uh, Suppose this is an object that has been kept on a surface here. Now when you applying any force from here in this direction, suppose you are applying 20 Newton force. Now you are applying a 20 Newton force, so it is having some magnitude, that is 20 Newton magnitude, and you are applying the force in this direction, so it is having a direction also. But there is one important point that you must keep in mind, that is the point of application. Point of application means that at which point the force is active. Now, coplanar forces. When talking about coplanar forces, then the force you can add by the summation of fx I vector plus fy j vector, because it is a 2D system here. So, in case of two dimension, only two directional you will be talking about, either x axis or y axis or z axis or x axis. Any of the plane you can take. Okay. In case of non-coplanar, you must take all the three directions for the addition of any force, because it is a 3D system. In x direction also, y direction also, z, addition of all the three directions. Now, what is a concurrent force system? Where the line of action of all the forces passes through a single point and forces lie in the same plane. When the forces lying on the same plane, that means it is a concurrent system, and same plane means it is a coplanar system. So you can say coplanar concurrent system, where the line of action of all the forces passing through a single point. Okay, so this is a force 1, this is force 2, this is force 3, and they all are meeting at a single point. That is, their line of action is at a single point. So when you are talking about concurrent force system, so there is a single point of action through which single point where all the forces are acting. So there is need of magnitude, plus we must know the direction, but point of application we don't know. In case of parallel force system, now in case of parallel means when the forces a line of action is parallel to each other. You can say the line of action of all the forces lie in the same plane and are parallel to each other. Then it is said to be a coplanar parallel system. When the forces lie in the same plane means coplanar, and when their line of action is parallel, that means they are parallel. So suppose this is a beam where these three forces are acting and these line of action is parallel to each other. So this is a coplanar parallel system, and in this case we needing value of magnitude plus direction of the force plus the point of application of the force. Okay, the third one is that general loading case, in which the line of action of forces lie in same plane but they are neither parallel nor concurrent, is inclined on the beam, whereas this reaction force Ra is going upwards, Rb is going upward, Ha going here, Hb will be going here, and it is inclined. So here also we need three things, that is magnitude plus direction plus point of application. So this is the force system. When we will be talking about same plane, that is the case of coplanar system, and when it is not at the same plane, when we will be talking about 3D case, that is a non-coplanar system. That you can easily understand with the help of an diagram that of a carom board. You can easily get the value that when you are playing with a striker, when you apply a force on the different coins, so it is either moving in x direction or y direction, so it is at the same plane. So this type of force system is known as coplanar force system, when all the forces are acting at the same plane. Okay, and when this coin gets lifted upwards or it is moving out of the board, that is having some height also, so it will be moving in x direction, y direction, z direction. So that is the 3D system. When you are talking, that is known as non-coplanar force system. So this is all about the types of force system. Now we will come up to the principle of transmissibility. So what is principle of transmissibility? There are certain principles you must remember. One is the principle of transmissibility. Transmissibility principle says, suppose this is an object, this is a body that has been kept on a surface here, and here we apply a force in this direction. So the principle says, if a force acts at any point on a rigid body. Now what is rigid body? That I have already told you, that the distance between the particle does not changes, in which the distance between the particles does not changes before and after applying the load. So if a force acts on at any point on a rigid body, it may also be considered to act at any other point on its line of action, provided the point is rigidly connected with the body. So it says that when, suppose this was an object here that has been kept on a surface here, when you apply the force here, so this is the line of action of this force. Okay, now the principle of transmissibility says you may consider this force. Here we have considered this force at A, now this is point B. So you can consider this force at B point also on the same line of action of this force. The force is acting at point A and its line of action is this one. Okay, line of action is this one. So in this line of action you can transfer this force at any point on the लाइन ऑफ एक्शन, इसी लाइन ऑफ एक्शन पे आप उस फोर्स को ट्रांसफर कर सकते हो. सो आई होप this point is clear, that if it may also be considered, this is also considered that at any point on the line of action, only at the line of action I am saying, only on this line you can transfer that force only on the line of action, provided the point is rigidly connected with the body. So this point is rigidly connected because this is the same part of the body. Okay, so you can transfer this force on the line of action of that force. Okay, so that is the principle of transmissibility. Now what is principle of superposition of forces? So principle of superposition says, if two equal, opposite and collinear forces are added. Collinear means lying in the same straight line, lying on the same straight line. Suppose this is an example of principle of superposition. Suppose this is an object here, okay, that has been kept on a surface here. Now this is the line of action of the force. Okay, suppose this is a force here and this is a line of action. Now here it is force 100 kilonewton. Okay, now here it is 150 kilonewton. At point here, at point, this is point B, this is point A. Okay, now somewhere inside this plane there is a force that is 150 kilonewton in opposite direction. So principle of superposition of forces says that if two equal magnitude but opposite in direction in same line of action, means collinear forces, are added to or removed from the system of forces, there will be, अगर इन दो forces को remove कर दिया जाए इस system से of forces, there will be no change in the system and position of the body. So this system will remain as such, either with these forces or without these forces. If there is this force, this is in this direction, this is in this direction, so they may cancel out, because one is trying, say, of same magnitude forces, there should be same magnitude forces and their line of action must be same. So they must lie on the same straight line. So they may be removed from the system, so there will be no change in the system and position of the body. Okay, so this is the principle of superposition of forces. Now the last one says that the principle of physical independence of forces. What is principle of physical independence of forces? Now suppose there is a system here. This is a object that has been kept on a surface. For example, I am taking. So one force is trying to move the body in this direction. Now one force is trying to move the body in this direction. This is force 1 and this is force 2. Okay. Now this force that I am talking about, the F1 force. Okay. Now this force will think that when there are several forces acting on an object, each one will act as if there is where the only one is acting. They don't affect each other. So the meaning of this statement is that the force will think that it is only working on the object and it will produce the same effect as it would have affected the object individually. Okay, so the effect of the force will be similar, either it is applied individually or with the group of forces. So the force will think that its effect should be applied similarly. So this is the physical independence of forces, that when there is a several forces acting on an object, each force will think that it is working individually. So they don't affect the other forces. One force will not affect the other force. So they don't affect each other. So you can sum them, vector sum. You can sum them or vector sum, because force, we are talking about force, it is a vector quantity. And you can determine all their components in the same direction and sum them to determine the components of the resulting force. So if they are in same direction, you can easily sum them up or vector sum them up, because of the principle of physical independence of forces, because one force effect will be same either on the single object, or when it is applied singly on that object, or when it is applied with a group of forces. So the force will think that it is only working. Okay, so it will try to move that object or affect the shape of that object with the same magnitude as it will applied individually or with the group of objects. Okay, so this is the principle of physical independence of forces. So I hope these points are clear. So thank you for hearing.